So, let us come to your next regarding RL circuits few examples, 4-5 examples, and with this your first order circuit will stop. I will not give you an exercise perhaps except one. So, I will suggest that you open any good book and try to solve some problem of your own, and whatever problems have been solved for this course, I mean you will not find much difference than others. I mean all varieties of problem have been considered, right. So, let us look into this circuit. So, it is you are given that figure, this is figure 58. Determine IT for t greater than 0. Assume that switch has been closed for a long time. So, this switch was closed for a long time, right. That means this current will flow, I mean it is getting a your what you call a short circuit path. That means this current will flow like this for a long time, the switch was closed, right. So, that means you assume that if the switch is closed for a long time, at that time inductor also will act as a short circuit. Then what will be the your current, initial current. So, in that case your what you call say I is equal to, it is 20 volt, right, divided by 4 ohm. So, it is 5 ampere, because switch was closed for a long time. So, current will flow like this. So, this will be inactive because it is a short circuit, right, and in that case you have to, your inductor will behave like a short circuit, your current will be 20 by 4. So, 5 ampere. So, let me clear it. So, if you look into this, that I 0 minus, that is initial inductor current, I told you that it will be 5 ampere, right. Now, what will happen, that that means current through the inductor cannot change instantaneously. So, when the switch is your what you call, when the switch is opened, current through the inductor cannot change instantaneously. So, I 0 minus will be equal to I 0 plus is equal to your 5 ampere. So, I 0 minus is equal to I 0 plus is equal to I 0 is equal to 5 ampere, right. Now, second thing is that this switch, actually this switch is now opened, right. If switch is opened, so this switch is open now, and at t is equal to 0, and suppose the steady state is reached. That means switch is open and steady state is reached, means inductor again will be short circuit. Therefore, my I infinity will be equal to 20 volt, and this is open now. So, this is your current will flow like this. So, this is my and this is my current, say I infinity at steady state. So, it will be 20 upon 4 plus 6. So, it will be 2 ampere. So, I infinity will be 2 ampere, right. So, let me clear it. So, in the here you will see that your I infinity your is equal to your 2 ampere, here it is 2 ampere, and if you look into the circuit, if you look the when switch is open, and when switch is open, so this is short circuit. So, what will be the R Thevenin? R Thevenin is simply, right, you just short this voltage source. So, it will be 6 plus 4, that is ohm, that is your 10 ohm. So, R Thevenin is equal to 10 ohm, and tau, the time constant will be L upon R, right. So, it will be 2 by 3 into 10, right. So, 1 by 115 second, that is your tau. So, let me clear it. So, if you look into that, everything has been made it here. If you look into that, tau is equal to L upon R Thevenin. So, 1 upon 15 second. Now, we know this I t is equal to I infinity plus I 0 minus I infinity to the power minus t by tau. So, I infinity is equal to 2, I 0 we have computed 5, I infinity again 2, and e to the power minus 15 t. So, it will be I t is equal to 2 plus 3 e to the power minus 15 t ampere, right. So, this is a simple problem, right. Similarly, if you determine I t for all the values of time, in the circuit, all the values of time means for t less than 0, for t greater than 0. This is the meaning, and look here, it is 5 volt is there, and here only 5 ut, that is one step input is also there for 5 ut volt, right, and this is 0.2 ohm, this is 0.6 ohm, and this is 0.3 Henry, right. So, one thing is there, that this is okay, this 5 volt is connected, but this is 5 ut, right. So, this is 5 ut means, this is you know that 5 ut means it is 0 for t less than 0, and it is 5 for t greater than 0, because ut is 0 for t less than 0, and ut is 1 for t greater than 0, right. So, in this case, suppose for t less than 0, suppose for t less than 0, that means this voltage source which actually it is 0. So, in that case, for if it is for t less than 0, then this will be, you make it like a circuit will be like this, because this voltage will be 0. So, make the circuit like this, right, like a short, right, and this 5 volt is there, and in that case what will happen, and if circuit remains for a I mean if it is like this, then at steady state the inductor will act as a short circuit, right. So, inductor will act as a short circuit. So, at that time what will happen, your initial current, this current direction is taken like this, that means it is like this, because it is short. So, this 0.6 ohm is not effective, nothing will go through this. So, current to 0.6 ohm resistance is 0, right. So, in that case your this initial current, that I 0 is equal to your I 0 minus is equal to I 0 plus whatsoever is equal to, it will become 5 by 0.2. So, it will be 25 ampere, right. So, that means my I 0 is equal to I 0 minus is equal to I 0 plus is equal to 25 ampere, right. So, this is because of this step input, this is for t less than 0, right. So, this is 25 ampere. Now, let me clear it. So, next solution is there later, right. So, now question is that for t greater than 0, at that time this 5 volt source will be there, right. So, at that time it is 5 volt, and t greater than 0 means ut is 1. So, this 5 volt is there, right. And if you think that your circuit at that time, your what you call that your circuit is in your steady state, right, then again again it will act as your what you call as short circuit at t greater than 0, and assume that it is reached to a steady state condition, right. In that case also it is short, nothing will be flowing through this, because this is a short circuit path. So, current will flow like this, So, in that case your I infinity, the steady state value, right, it will be 5. If you apply KVL here, you look I am writing for you. So, if you apply KVL in this there, it will be minus 5 plus 0.2 into I, again minus 5 is equal to 0. Therefore, my I is equal to your 10 divided by 0.2, that is your 50 ampere. Actually, this current is basically I infinity. So, this current, this is actually I infinity is equal to I. So, it is 50 ampere I infinity. So, I 0 is equal to 25 ampere, and I infinity is equal to your 50 ampere, right. So, steady state value. Let me clear it. Now, to get that your what you call, to get that your R Thevenin. So, this source should be short and this source should be short. So, 0.2 ohm and 0.6 ohm are in parallel. So, R Thevenin will be equal to 0.2 into 0.6 divided by 0.2 plus 0.6, right. So, it will be 0.2 into 0.6 divided by 0.8, right. So, it will be your 0.4. So, I think it will be 1.5 ohm, right. So, and tau is equal to L upon R, your L is 0.3 Henry. So, you can easily compute tau. So, all these calculations how has been made, I showed you. So, now come to this solution. So, in this case R Thevenin is coming around 0.15 ohm, right, whatever it is, and this is tau is equal to L by R Thevenin coming 2 second, and by definition 5 ut is equal to 0 for I told you less than 0, and it is 5 for t greater than 0. So, I 0 minus I told you it is 25 ampere, I 0 is equal to I 0 plus is equal to I 0 minus 25 ampere, because at the time of switching current to inductor cannot change instantaneously, right. And for t greater than 0, I infinity I told you it will be 50 ampere, I showed you, right. Now, we know from this for t greater than 0, we know that I t is equal to I infinity plus I 0 minus I infinity to the power minus t by tau, right. So, you substitute all these values, you will get I t is equal to 50 minus 25 to the power minus 0.5 t ampere. So, t greater than 0. Therefore, for all the time means it is I t is equal to 25 ampere, the initial value for t less than 0, and this is for t greater than 0 50 minus 25 to the power minus 0.5 t ampere, that is for t greater than 0. Or simply you can put it in a like this, I t is equal to 25 right, plus 25 minus e to the power minus 0.5 t ut. Actually, this one your these two have been your what you call have been your combined together, right. So, that is why ut is made. Therefore, IT is equal to once again I am writing, note that for t less than 0 ut is equal to 0 and for t greater than 0 ut is equal to 1, right. So, this hope you have understood this, right. Now, next take another one. This is this problem is a little bit interesting. So, in figure 60, right, I will show you the switch has been in position A for a long time, right, and at t is equal to 0 it is thrown to position B. Determine, you have to determine A, that is I t for t greater than 0, then B V 0 minus, then V 0 plus and d I by dt 0 plus, right. All these things we have to determine. So, this switch has been in a position A for a long time and at t is equal to 0 it is thrown to position B. That means, in this problem switch was at position A for long time, that means circuit has reached steady state, right. Circuit has reached suppose this one it was positioned like this for a long time, at that time inductor is behaving like a short circuit, right, and current through this, that initial current, that is I 0, it will be 12 volt, and if you apply KVL here, if you apply KVL here like this, it will be 12 by 12 volt by 12 ohm is equal to 1 ampere, right. So, this is your I 0 is equal to I 0 minus is equal to I 0 plus, that is your 1 ampere, right. Now, at t is equal to 0 the switch has been thrown it here, right. So, this part is isolated, switch has been thrown it here. So, at that time also you have to find out what is your I infinity say first, and I infinity means suppose at t greater than 0, suppose it has reached to a steady state. So, again it is short circuit, at that time current flowing through this is I infinity, that is the steady state value, right. So, in that case it is 2 into I infinity is equal to 6. So, I infinity is equal to 3 ampere, right. So, I 0 is equal to 1 ampere and I infinity is equal to 3 ampere, right. And where let me clear it, right. So, this is your I 0 minus is equal to 1 ampere. I told you I 0 is equal to I 0 minus is equal to I 0 plus, that is 1 ampere, and at t is equal to 0 switch is in position B, right. So, in this case when switch is in position B, when switch is in position B, so it is very simple, R Thevenin is equal to 2 ohm, because this from this 2 point you are looking to get that R Thevenin, and at that time you are making this voltage short. So, basically it will be 2 ohm. So, R Thevenin is equal to 2 ohm, right, and L is given 1 Henry. So, you can easily compute your time constant, right. So, in this case your tau is equal to L by R Thevenin. So, L is 1 Henry and R Thevenin 2 ohm. So, 0.5 second, and I infinity I showed you that it is 3 ampere. How to get it? It is 3 ampere, right. So, because switch is in position B and the circuit reached a steady state. Now, for t greater than 0 we know that I t is equal to I infinity plus I 0 minus I infinity is equal minus t by tau. So, you substitute all this value I infinity, I 0 and tau, you will get I t is equal to 3 plus 1 minus 3 e to the power minus 2 t, or you can simply write 3 minus 2 into e to the power minus 2 t ampere, right. So, that is for t greater than 0. Now, second thing, when switch was in position A under steady state condition, inductors act as a short circuit, right. So, in this case your, because from there you can easily find out, right, because here I mean when switch was in position A, so inductor is behaving across a short circuit and this is the voltage across the inductor. So, and current through this is 1 ampere, this is your I 0 minus is equal to I 0 plus, right, is equal to I 0 is equal to 1 ampere, that we have seen. So, if you apply KVL like this, because inductor is acting as a short circuit, so it is 12 into 1 because current flowing through this is 1, right, plus V minus 12, this minus 12 is encountering minus is equal to 0. That means, my V 0 minus, it actually it will be, first let me write down, it will be V is equal to 0, which is nothing but V 0 minus is equal to 0 volt, because at that time this circuit this your switch was in position A for a long time. So, it is V 0 minus is equal to 0 volt, right. So, let me clear it. So, that is why your V 0 minus is equal to 0 volt. Now, at t is equal to 0, when switch was placed in position B, we apply KVL. So, when switch is in position B, I will look into this circuit. When switch is in position B at the here at the position B, so you apply KVL. At that time, say it is suppose that current is equal to your your what you call I 0, your I 0 minus is equal to I 0 plus, right. So, here you apply KVL in this loop, you apply KVL, right. So, if you do so, you will get this this one your 2 I 0 plus V 0 plus minus 6 is equal to 0. Just in that loop you please apply and take I is equal to I 0 plus, because at the time of switching current cannot change to the inductor instantaneously. So, you will get 2 I 0 plus V 0 plus minus 6 1, I mean this one, right. So, if switch is in position this one, at the just at the time of switching, the current flowing through this is I 0 plus, right. So, it will be, if you move like this, it will be 2 into here I am writing, it will be 2 then I then 0 plus, right, plus V minus 6 is equal to 0, but I 0 plus is equal to 1. So, V will be equal to your actually it will be V 0 plus, right, V is equal to V 0 plus, it will be 6 minus 2 is equal to 4 volt, right. So, let me clear it. So, here your this is your V 0 plus is equal to 4 volt, and we also know generally we know V is equal to L into di by dt. So, as V 0 plus is 4 volt we know, so we can write L into di dt 0 plus is equal to V 0 plus. This has been asked. So, di dt 0 plus has been asked to find out. So, di dt 0 plus will be VL 0 plus V 0 plus upon L. So, L is 1 Henry and V 0 plus is 4 volt. So, it will be 4 ampere per second, right. So, little bit understanding is required. Now, next is this problem. Listen, this particular the switching, that DC transient, the switching thing, only thing is that our understanding has to be very clear, then only one can easily solve it. In no time you can solve it, but just one has to see that how things are happening. Now, in this figure the switch has been open for a long time, that means this switch actually was open for a long time, and your what you call, and if the switch is closed at t is equal to 0, determine I t. So, this switch was open for a long time means that inductor is behaving like a short circuit, right, and it was open for a long time, therefore, you find out what is your I 0, and I 0 is equal to at the time of switching I 0 is equal to I 0 minus, and at the time of switching it is I 0 plus. So, it will not change, right. So, in that case if you try to find out I 0, it will be 4 divided by 2 ohm and 2 ohm, because it was open for a long time. So, it will be 4 upon 4 is equal to 1 ampere, right. This is 1 ampere. Now, so this is I 0, and I 0 is equal to just before switching I 0 minus is equal to just after switching I 0 plus is equal to 1 ampere, because current through the inductor cannot change instantaneously. Now, let me clear it. Now, this switch is closed, right. That means this switch is closed now. So, in that case this is inactive, right, it is sorted. So, and suppose and circuit has reached to a steady state. So, inductor acting as a short circuit, right. So, you make it like this, therefore, my I infinity will be is equal to your 4 divided by 2, because only 2 ohm resistance is active, because current path will be like this, it will be like this, right. So, this is not there because it is short circuited. So, it will be 2 ampere, that is my steady state value, that I infinity, right. So, let me clear it, and as switch is closed, as this is closed, and if you your what you call, so circuit path is like this, that this is the closed circuit, therefore, my R Thevenin, this is also you can short it for getting R Thevenin is equal to 2 ohm, it will not come, because after closing the switch this is becoming inactive, right, it is shorted. So, it will be 2 ohm, that is your R Thevenin, right, and you can find out tau is equal to L by R, time constant. So, everything I said here, right, though I 0 minus it is 4 ampere, R Thevenin is equal to 2 ohm I told you. So, tau is equal to L by R Thevenin, L is 1 Henry, so half second, and t tends to infinity, that is I infinity I told you, it is 2 ampere, and for t greater than 0 we know this one, that I t is equal to I infinity plus I 0 minus I infinity to the power minus t by tau. If you substitute all the values I infinity, I 0 and tau, you will get I t is equal to 2 minus e to the power minus 2 t ampere, right. Now, if we want I t for all t, then I t is equal to 1 ampere for t less than 0, because I 0 minus is equal to 1 ampere, and it will be 2 minus e to the power minus 2 t ampere for t greater than 0, right. Therefore, we can write this equation, that I t is equal to 2 minus e to the power minus 2 t is equal to, we can write like this, 1 plus 1 minus e to the power minus 2 t u t, right. So, this is your I infinity, this is your this 1 plus 1 minus e to the power minus 2 t, right. So, this way you can write your what you call, when u t is equal to 0, that is t less than 0, it is 1 ampere, right, and when u t greater than 0, u t is equal to 1. So, it will be because 1 plus 1 e to the power minus e to the power minus 2 t. So, 2 minus e to the power minus 2 t, right. So, this way you can write. So, that is why it writing, note that for t less than 0 u t is equal to 0, and for t greater than 0 u t is equal to 1, right. So, this is, hope this problem is understandable to you, right. So, now in another thing is that in figure this thing at t is equal to 0, figure I will show you that switch S1 is closed for and 4 seconds later switch S2 is closed, determine I t, calculate I for t is equal to 2 seconds and t is equal to 5 seconds, right. So, at t is equal to 0, switch S1 is closed and 4 seconds later S2 is closed. So, this is the circuit. So, at t is equal to 0, that your at t is equal to 0, this switch S1 is closed, right, and at t is equal to, and 4 seconds later this S2 will be closed, right. So, at that time S1 and S2 after 4 seconds both will remain closed forever, right. So, let me clear it. So, at I mean when this your what you call that this initially this switch, this was also open and this was also open. So, that means this voltage source has no effect, this voltage source has no effect, right. So, if you look into this, just hold on, if you look into this, right. So, initially that your, as this is open, this is open. So, initially this I 0 is equal to your 0, that is equal to I 0 minus is equal to I 0 plus, right. So, this is 0 because this was open and this is open. Now, this this S1, this one is closed, but this is open, right, but this remains open. S2 will be closed 4 seconds later. So, this is closed, and that means this is the path, right, this is the path, this is open. So, this branch has no effect, right, and suppose this this steady state, the inductor is acting as a your short circuit, right. So, in this case if it is so, then what will be the your what you call that your steady state current, that is infinity for when S1 close, I infinity. So, I infinity will be, this is 4 ohm and 6 ohm, this is 10 ohm are in series and this is the 40 volt. So, it will be 40 by 4, that is your 40 by 10 rather, sorry, let me this is 10 is equal to 4 ampere. So, I infinity is equal to 4 ampere, right, that is your, an initial value of I 0 is equal to 0 and I infinity is equal to 4 ampere. Now, here let me clear it. Now, here if you try to find out that what will be the time constant, this is your, this is closed, this is open, right, and your to get the your R Thevenin for this case, but this is open, S2 remains open, R Thevenin voltage source should be shorted, right, and R Thevenin will be equal to, you are looking from this terminal, this is open, it will be 6 plus 4 is equal to 10 ohm, this is R Thevenin, and tau is equal to L by R Thevenin, right. L is equal to 5 Henry and it is your 10 ohm is equal to half second, right. So, with this everything I said, right, with this I infinity 4, R Thevenin 10 ohm, L tau is half second, and we know this formula I t is equal to I infinity plus I 0 minus I infinity is equal to minus t by tau. Put all these values, you will get I t is equal to 4 into 1 minus e to the power minus 2 t ampere, that is in between 0 and 4 second, because switch S1 is closed, right. Now, for t greater than 4 second, now at t greater than 4 second, this is closed, and this is also closed. That means, we will assume these two switches are closed forever, right. So, I mean this is also closed, at t is equal to 4 second, this is closed, these two switches are closed forever, right. So, in that case again you have to find out your what you call I infinity and your initial value at t is equal to 4 second, that is at t is equal to t 0 is equal to 4 second, you have to find out what is the initial condition and a steady state what is the final condition, and then you have to find out the expression for t greater than equal to 4. So, in this case I hope you will understand this, right, when both switches are closed, right. So, S2 is closed, this means S1 and S2 are closed forever, right. So, sudden closing of S2 does not affect the inductor current, because the current cannot change abruptly to the inductor. Thus, the initial current is at t is equal to 4, you put at t is equal to 4 in this expression, here I t is equal to 4 1 minus e to the power minus 2 t, here you put at t is equal to 4, because the switch S2 is closed. When you will solve this problem, all this problem, when you will see this, first you will draw the circuit on your notebook, after that you see what is happening, right. When you read this video lecture for all the time, you will see that first you draw the circuit on your notebook and then you will try to solve of your own before looking into the solution or what I am telling, right. So, you put t is equal to here 4 second. So, you will find that I 4 is equal to I 4 minus is equal to I 4 plus, right, approximately 4 ampere, because 1 minus e to the power minus 8, e to the power minus 8 is too small. So, approximately 4 second, that is t is equal to 4. Now, let V be the voltage at node A. So, in this case now suppose steady state is reached, this one steady state is reached. So, this is closed, this is cold, and this is your node A, this V means your V infinity, right, the steady state value at that time, this your it is short circuited, right. So, at that time you apply your what you call KVL, this voltage is V volt 40 volt, right, because this 40 volt, and here it is your 10 volt is there, right, and this V infinity means this is the your what you call this voltage across your, this is short. So, 6 ohm your resistor. So, your nodal analysis we have already studied. So, directly I am writing this equation, right, as this your what you call this applying your KCL at node A, V is equal to nothing but V infinity. So, in this case you please you when you apply that your KVL, that is of 40 minus V plus 10 minus V by 2 is equal to V by 6, V is nothing but V infinity, right. So, let me tell you once again, this V is nothing but V infinity, the steady state when inductor is acting as a short circuit, right. So, if you solve this V, actually this is V infinity. So, it is 180 upon 11 volt, right. So, in this case I infinity will be V by 6, because across that 6 ohm resistance your voltage, this nodal analysis we got this V infinity. So, it will be your V by 6, that is 180 upon 11 into 6, because V infinity is equal to 180 upon 11. I did not write V infinity, but it is understandable, that is your 2.727 ampere, right. So, let me clear it. So, the Thevenin resistance at the inductor terminal is, if you look into that, very simple, it will be 6 plus 4 into 2 upon 4 plus 2. I need not go back to the circuit, you draw the circuit on your notebook and just you can easily get it. It will be 22 upon 3 ohm. So, tau will be L upon R Thevenin. So, 5 upon 22 by 3 is equal to 15 by 22 second, that is tau. So, from equation 75 we know this, because it was t is equal to not 0, t is equal to t 0, that is 4 second. So, that is why your from equation 75 it is I infinity, then I t 0 minus I infinity e to the power minus t 0. So, it is basically I infinity, I t 0 means t 0 is equal to 4 seconds. So, t I 4 minus I infinity t 0 is equal to, actually it is 4 seconds, because S 2 was closed after 4 seconds. So, if you put all this value I infinity, I 4, I infinity and t your tau value. So, you will get I t is equal to 2.727, then 4 minus 2.727, then e to the power minus 22 by 15 into t minus 4. So, I t will be coming your 2.727 plus 1.273 e to the power minus 1.467 t minus 4. This is ampere for t greater than equal to 4, right. Let me this thing. So, putting all this together, we have that I t is equal to 0 for t less than equal to 0, that we have got initial value of I 0, and for 1 minus e to the power minus 2 t for in between your t greater than equal to 0, less than equal to 4, and for t greater than equal to 4, this one we got it, because two switches were there, and it has been asked to find out at t is equal to 2 second what is the value of I. So, I 2, that is at t is equal to 2. So, 4 1 minus e to the power minus 4, it is 3.93 ampere, and it is asked also at t your 0.5 second. So, it will be 2.727 plus 1.273. So, 1 minus 4.67 is equal to 3.02 ampere. With this we will close that first order DC circuit. As many as 23 problems have been solved, different type of problems. With this I believe all the parts of the DC portions have been covered. So, from the next next lecture we will go to that single phase AC circuit, and DC circuit we have solved several problems. I mean several problems for all 6 chapters, but in AC circuit as complex number will be involved, and because of that we will restrict the number of numericals, maybe 7, 8, 9, 10 for each chapter or even less, because complex number involved. But any good book when you will follow, you will solve the problem. So, we will see that single phase AC circuit from the next video lecture. So, thank you very much.